Hello Internet, my name is Sheridan and this is my Analog 101 course. So today I'm going to be talking about inductors. Inductors are fairly simple. They're just coils of wire that create a magnetic field. So inductors can be thought of as the opposite of a capacitor. An ideal capacitor has infinite resistance and an ideal inductor has zero resistance. The purpose of a capacitor is to store charge, and the purpose of an inductor is also to store charge, but instead of using an electric field, it stores charge using a magnetic field. So let me demonstrate what inductors do. Math for inductors is the same as our capacitors. It's just it's measured in henries and symbolized with an L in our formulas. And it's just your time constant is multiplied your resistor times your inductor, and it takes 5 time constants to fully charge and fully discharge. Same as a capacitor. So the one drawback of inductors that makes them unlike capacitors is that you cannot pause charging and discharging. Actually, maybe you can. Okay, maybe you can. So inductors, I will test that out in this video. So the way that we paused the charging of an inductor or of a capacitor was by breaking the circuit. So I think shorting out an inductor will actually pause the charge and discharge of the inductor. I think. I will test that out. So at the end of this video. So let me demonstrate what inductors do when charging and discharging and breaking the circuit and whatnot. So right now we have our inductor fully charged, and it says picovolts, but this is essentially 0 volts across the inductor at full charge. We are assuming there is some resistance in the inductor. That's probably where the picovolt measurement comes from. And as you can see, our voltage drop is essentially fully across this resistor at full charge, and there is current flowing through it. You have momentum. You have current momentum in this circuit. So let's switch to our discharging circuit. And as you can see, the current is being pulled in the same direction across the inductor, in the same direction that it was flowing when it was charged in our charging circuit. And so it essentially, because it's giving those electrons momentum, it creates a vacuum on this side of our inductor. So we can open up our circuit to see what the LED, or open up our switches to see what the LEDs do. So when we charge our circuit, you can't really see it in this example, but when we first charge up our circuit, the LED does not turn on until the current gets going. Let me see if I can slow this down and show you. I'm going to increase our resistance. Let's make that 500. So changing your resistance will change the maximum current that that your charging and discharging circuits will limit itself by. Okay. So as you can see, eventually the equivalent resistance of an inductor drops to 0, so all of our resistance of the entire circuit will be determined by this resistor. That will determine our resting current, so to speak. So yes, As you can see, we got the LED to turn on for a little bit, but it didn't stay on. The reason I have this resistor here is because inductors do have something called kickback, or recoil. And what that means is if the inductor has no path for it to discharge the momentum in, then it's going to sort of oscillate within itself, because it's constantly breaking down and building up a magnetic field that it can't get rid of that energy, so it's going to sort of oscillate until it has a way to discharge itself. So I'm going to increase our inductance and see if we can get a longer time constant out of that. So we did get a longer time constant. You can see, yes, you can see that the LED started off dim and then grew brighter over time. So I am now going to test out my hypothesis on whether we can pause charge and discharge by shorting out our inductor. So I'm going to make a shorting switch across our inductor. So we're fully charged. And increase our time constant. Close that. Charge our inductor. Slow our time speed down. Switch to discharge. Would you look at that? I was right. We are maintaining a discharge pause. However, it only pauses... Okay, so it only pauses current, it does not pause voltage. The same way, well, yeah, if you were to open up the circuit on a capacitor, you would pause the voltage and not the current. Huh. Well, that about covers what I wanted to cover for today. So inductors are also used in filtering, like I said, and we will cover filtering and timing and frequency later. So I will see you next time. Sheridan out.